This part here is our final arm segment number 1. This is the arm segment that gets connected to the base piece through the pegs at the bottom and the screw holes that you can see the two of them near the bottom. And it connects to the second arm segment using a friction hinge, which can be seen in the assembly video. The first feature of this design is a long cylinder extrude. This extrude is 63.5 millimeter diameter as the sketch is and 150 millimeters high. The diameter and height for this one chosen was such that it could fit well into someone's hand when trying to move it, and it had enough size that it could be lengthy and reach have to give the arm a lot of reach. Immediately after, the first thing we do is put a cut extrude in the middle, as we want to limit the total mass of this arm so it's easy to move and there isn't many issues. The way we did this was making a 48.5 millimeter diameter for this cut, which is 15 millimeters smaller than the outside diameter of the tube, making it 7.5 on from each side, or from this edge to the cut edge, and giving it that amount of wall thickness. The extrude is done such that it goes up till this point here, 20 millimeters above the bottom, and starts 12.5 millimeters from the start. The reason we have more space on the bottom than we do on the top is we want the weight distribution to be slightly downward so that it doesn't create as much force at the top when the center of gravity is moved away from the base. The next thing we did here was we added a boss extrude. This boss extrude is 12 millimeters thick in total, 6 from each side, and it uses the edge of the circle through convert entities to make sure that this extrude fully aligns with the circle and is not just a rectangle. Through doing this, we then put the extrude to be 25 millimeters tall, and the reason for this is such that the depth total is 12 millimeters because we need 8 millimeters depth for our heat inserts, and the height is 25 millimeters because that is the accommodated height we need for the friction hinges that we purchased off the McMaster car to fully be able to be mounted on this extrude and not interfere with anything else. This leads us back to why we chose the diameter we did, because this extrude right here is just long enough to where it's just a bit wider than the face of the friction hinge that it is screwed into. So that's how we landed at the outside diameter of the cylinder to be 63.5. From there, we then put 2 extruded cuts. The where we put these cuts was determined, again, the same way as it was in the base piece, through an external reference to our assembly. We determined the size we need for this face in the previous extrude through the dimensions of the friction hinge, and through that we could also tell the diameter of hole we needed and the distance between them. But to make sure that it was aligned perfectly, instead of just putting 8.75 millimeter diameter hole, because that is the outer diameter of our heat inserts, or M6 heat inserts, and instead of just putting that diameter hole the set distance away from each other, we did it through the reference so that we could see the exact height to put the cut extrude circles such that the friction hinge face ends where the ledge here face ends, and those two edges meet right here. After that, we put fillet here, which is a 10 millimeter fillet, and another one here on this edge, which is a 5 millimeter fillet. This is just to create more smooth edges and structural support for these extrudes, so it's more visually appealing. After that, we put in our first peg at the bottom. This is the same peg that goes into our base piece shown previously, and this was made before the base piece as was shown in that video, so that the reference geometry was made through the assembly. This piece has a 9.5 millimeter diameter, as the holes that we put into the base piece were a 10 millimeter diameter, so that there's a little bit of clearance. And we made it to where the center of this circle was 20 millimeters from the center of the cylinder, and it's directly vertically aligned with our origin. After doing this, we created a circular pattern to replicate 6 of these. And you're all 15 millimeters extruded to go into our 16 millimeter holes in the base piece. So there's a little bit of extra room there. Then we placed fillets here of 10 millimeters and here of 5 millimeters for our internal hollowing out. We could have done this earlier, but it's later in the tree because that was when it was done. Now here we added a reference geometry plane. The reason for this plane was to put it exactly 30 millimeters away from the center, which, as if you recall, this entire piece is 63.5 millimeters diameter, so the radius from one side to the other is 30.175. This is so that we can do our next piece, which is the cut extrude into our wall. The reason for this is such that there can be a flat surface to then put our next cut extrude that puts our heat inserts in instead of putting it in through a circular surface. This flat surface with the very minimal cut in goes exactly halfway. The middle point of this surface is exactly halfway through the diameter. It is 12 millimeters across and 15 millimeters tall, in accordance with the exact same extrudes that are corresponding on the base piece. Then we put a hole through it. It's the same dimensions as the one prior. It is 8.75 millimeters diameter and 8 millimeters depth, allowing us to have our heat inserts placed inside. And we put a pattern, so there's another one directly across it. The choice was that one of them, between the base piece and the arm segment, one of them would only need 2 and one of them would need 6, because no matter how you rotate it, this would be such a way that you can lock both of them down. But we decided it would be easier to put the extrudes, 6 of the extrudes on the print instead of 6 of the cuts in this one. But as we put 6 cuts, we would need 6 heat inserts. Also, we decided for the these cuts to come parallel to or perpendicular, but the plane, to make these cuts on to be parallel to the right plane, so that these cuts, as you can see here through the material, so these cuts don't go directly above where the pegs are, so they have the most support possible. Thank you.